The title just says Swift. I hope that's adequate enough. Swift. Coding. Writing Swift code. How about that? Destination internal blah blah blah. Okay. Maybe Swift is good. It's like clickbaity. It's like Swift. Taylor Swift? Holy shit. So hello everybody. I'm not sure what's going on. I'm trying out this new feature on this website, and the website claims it's still sending data to Twitch. What does that mean? Am I not live? I'm live. Cool. Okay. I'm gonna assume things are working. Well, assume is a bad thing. Let's verify. But I'm gonna do it very quickly. Oh, that is not my URL on YouTube. Okay, good. Actually, is this just a thumbnail? I hope. Okay, cool. What about? Aha. Nice. All right. So yesterday we struggled a bit trying to implement the metadata fetching logic for our file system library in Swift. And, all in all, things worked out pretty well, I'd say. Let's see. Okay, so that's some random character, probably randomly typed. Just make sure things are, synced up. Uh-oh. Forced update. Okay, this looks great. All right, so what are we doing? First of all, I wrote a sample app. So if I run Swift run metadata, so this is a new target that is like a executable. And then it takes a path as its only argument. It will build this sample app and it will call our metadata app. So the great thing about this is I can run this app in different platforms, and it's kind of like a QA test, right? Like only I can eyeball this. Like for example, we can say the current directory, then it tells us it's a directory. By the way, these are the public interfaces in the common public interface for metadata. So you get this running on both Windows and Linux and Mac OS. Unfortunately, because of what we did yesterday, it won't work on BSD at this point, which is a shame. But we can get there when we need to. Essentially, we need the B time, the burst time of a file, and that's in statx, which is a feature in Linux kernel. So you have to import Linux headers, specific headers. But I know that it is part of a later version of glibc now. So, one way to think about this is like maybe some years down the line we get to adopt it. But anyways, for now, like if we were to test our things on our library on a BSD distribution, we'd have to change the implementation a bit. my stream frozen? Okay, doesn't look frozen, right? Cool. Cool. All right. So, yeah, so that's one thing that happened off stream. But this stream, I want to implement metadata for Windows, and I tried a little bit offline, and I'm running into some issues. So let's just jump in and try to debug. Try to see what is the issue. So for the majority of the stream, I'm going to look like this, because this is how I face my Windows computer, and I have to adjust my mic a little. I'm afraid, or maybe the audio can be a little quiet, but should be okay. So let's switch to a Windows terminal. So what you're looking at now is the Windows terminal app, and yeah. So here we are. On the left is a PowerShell session. On the right is whatever shell running Vim. It's PowerShell as well. But let's just look at where we are. So I've made a bunch of changes. So these batch files are my things I don't check in, but I rely on them to build and test on Windows. And these are, I guess, the files I created so far to implement. Oh, I made some changes in metadata. Let's see. Let's take a look at metadata. So yeah, it's just for debugging, but we can get rid of those. So examples, metadata main. Yeah, we can get rid of these debug files. So this is the metadata app, by the way. Guess I can just undo everything. And this is what it is in the main branch. It takes the argument, creates a path from it, and then it just calls the metadata method, and then it prints out each field in the metadata method. That's it. Simple. I believe that let's just go through the changes we have so far for Windows. Yeah, so made a new file, and the file implements the metadata method. Well, can you see my cursor, by the way? I hope you can see my cursor. Okay. Also, probably want to, let's see. I want chat, so I need to bring up chat here. Maybe I can bring it up on the Mac computer that I normally code in. It's going to be a bit of a struggle, but we'll get through it. String monitor. Streams, chatters, messages. No, these are just some stats. I want the actual messages. Okay, this looks like a chat bubble. You need to go live to unlock the chat. But I'm live. Okay, whatever. I'll just use chat on the same Windows computer. All right. Okay, so yeah, so I tried two different things to implement the metadata. So on Windows, there's this thing called get file information by handle, and there's the extended version, so same name with the EX at the end. And then there's find first file find first file. And find first file, I think, because it's for finding files, it takes like a pattern. So my conclusion is like it sometimes doesn't work if you just give it. Anyways, I think the get file information by handle is the way to go, probably, unless. Anyways, I think the last time I actually tried this code, like running it, something went wrong. Oh, Can I increase the font size somehow? Okay, this looks like it's doing the thing. And it broke. It broke Vim. But hopefully, yeah. Things are a little quirky on Windows, to be sure. Okay, so path plus Windows. Okay, so the way you call this method is you create a file handle and then give it various flags. These are chosen for very specific reasons that I won't go into right now. And then you get to create a pointer, and then you pass both the file handle and the pointer to your struct into the method you want. And then you get this out, right? So I think the problem I ran into, let's try it. Maybe it's fixed magically. You never know, right? So this script should have enough environmental changes so that I can just run things like build, for example. So this will call the build.batch file. And as you can see, it builds a bunch of stuff, notably our executable here. So I can go into build windows bin and run metadata.exe. And we didn't get anything. But clearly we tried, if you recall, to call this method, right? And if I say print something earlier, say here, right? Come back here. Oh, this probably needs to blow up a little bit too. Okay. All right. Is that big enough? Hopefully. Let me know if you want it to be bigger. Okay. So build again and run it. And we didn't get our thing. So there's a few reasons, but what really confuses me is like it appears that whenever we throw an error, we don't get any output on Windows. It could have something to do with my build configuration, so we can take a look at that. Examples, metadata main. Yeah, so this is, we import in pathos, we just run it, right? We just straight up call metadata. So we should get something. Maybe we need to put this even earlier. Let's put it here. This is the last trial and error. I'm gonna try. Create a library and object metadata. It didn't say it rebuilt metadata. That's something. What if I just straight up do this? Make build Did it build our binary? It did. And our binary didn't output anything. Awesome. Not. Okay. Maybe error is like a silent thing. I don't know. I'm going to try until we get a print, right? We should be able to run hello world and get something out. What if I run test just for the shits and giggles? Wait, running test somehow ran our binary. Wait, where is this from? Okay, maybe something is wrong in the CMake build. Let's take a look. CMake list, add subdirectory, make list, add subdirectory examples, and subdirectory tests. If build examples is yes. Now we can take a look at examples. The directory examples has metadata, which builds this file, and then we link to the pathos library. Things look right. Do I have ACK on here? Probably not, huh? Do I have RG? Oh, I have RG. Nice. So Windows is not bad, all things considered, for development. So path plus Windows. So I'm just wondering which one of these got printed out when I run test. Oh wait, I didn't give this a argument. There we go. So it was failing silently. Okay, that was a face palming moment. Okay. I'm gonna assume this is not getting printed, right? Let's build or test. Run this. Yeah, so that's not getting printed. It's the other one. So good, we're back on track. Okay, so this is what we are seeing there. So let's move this down and see. So we also learned that because I didn't add this argument, the array was out of bound when I accessed it, and the access to the array was out of bound. But we just got a silent treatment from that, which makes me wonder, what is the build configuration here? I think it's in scripts, make. So we're building release with debug info. Maybe let's try debug. How about that? I'm just gonna start over. Script make. And then build. It's building, it's thinking. Very nice. Also, I can full screen this, right? I don't see a reason to. It doesn't matter. Okay. So now if I run that binary. Oh, yes. I guess debug build is what we want. Nice. So what if I don't provide this input? It should tell us something about index outer range. Perfect. This is what I want. Okay. So what is this error? Line 35. Let's take a look. In path plus Windows, right? 35. Font nil. Oh, yeah. Okay, that's actually good. So that means, first of all, we opened the file correctly. We just had an unfortunate incident where we created a nil pointer. So what is the appropriate way to do this? Okay, so I guess I'll have to do it's file by handle file information. Is that what it's called? I can learn that from here. Yeah, so it's this structure. Okay, so let's just make an incidence of that. By handle file information. Is this okay? And then I give it the address. I use the LP thingy because that's what's in the Windows type declaration. Oh, right. So we don't need to do .t anymore. So that's actually pretty nice because we're not working with pointer, unsafe pointer in Swift. Okay. Now we're talking about fatal error, blah, blah, blah. But I think we got our value back. We got our struct back. That's really, really good. Nice. This is actually going pretty well, all things considered. Okay, so now we're seeing a fatal error that's actually I wrote. So as you can see, it's right here, right? Okay, I'm gonna just delete this for now. Let me think. So this also makes me wonder if this other thing will work as well. So let me try that as well. I'm going to restore this and kind of. I think when I was offline and trying this, because I'm not using debug build, so I'm not seeing all these errors. So I just quit at some point because it's not super obvious what's going on. But let's do the same thing here. Make a var of the struct and give the pointer to our function. And then when print out, we can print or dump. Dump is probably better. And then we fatal error, okay? So I'm gonna build this. Info, all right. It's not info, it's data. Also, yeah, I connected my mechanical keyboard to the PC, so that's why you're hearing the. If you watch some of my old streams, that's the keyboard I used in those streams as well. Oh, we're getting stuff. We're getting stuff. So this looks like a tuple, and then we're getting. Oh, so this works as well. So let's compare, right? In this data structure, we can just look at. Let me just show you on the Mac. Yeah, I'm gonna switch to Mac. Okay, so this is the data structure we were looking at, and it has the file attributes, which I'll get into later, file size, the 3 times we're interested in, and this reserved bit, which is actually super useful for me. Oh, I think the real test is what if I give it a file? Well, it gives me information about the file. It did, right? It totally did. Okay. Now, open. How do I want to make a symlink. So one interesting thing about this is like this specific bit I'm highlighting. Oh, let me see. What are you guys saying? Okay. This reserved value is going to be used for determining whether something is a symlink. And from what I read in the documentation, symlink is added for compatibility with POSIX systems. So that's why it's not built in. It's kind of patched in their API. So I want to see if this value changes, which means I need to try to make a symlink. Let's see. Sorry, I'm not showing you what I'm doing here because I'm not sure what's in here. But, this PC, to be honest, I don't use it at all. So it's not like I'm afraid of showing anything. No cap, but still, it's not terribly interesting what I'm doing. Okay. Yeah. So how do I make a symlink? How to make a symlink on Windows? Is this just one of the shortcut thingy? How to create a run as an administrator. Make link. And then you do link and target. Okay, let's try it. Switch scene so you guys can see. All right, and then let's make a symlink. So make link. Is this a thing in non-Windows? I mean, in PowerShell? Okay, it's not. So let's switch to command line prompt. Make link. Okay, so this thing exists. And then we want a link. So package link dot swift. And then the target is package dot swift. You do not have sufficient privilege to perform this operation. Poggers. Let's do command line prompt. Now you guys can see that. So what if, let's go 5 head, switch back to the Mac, and let me show you here. How about that? Let's SSH into the Mac, the Windows computer, and then we can go to source, Duan, pathos. Oh wait, I'm not a command administrator here neither. Okay, never mind. So how do I do this? Let me add command prompt. All right, no, I'm just gonna show you the desktop, or if I can. I cannot. Okay, not easily. Anyways, so let's just go to window capture. Okay, there we go. Nice. Yeah, it looks pretty good. It's big. Okay. So I need to close this and rerun it. Command prompt, run as an administrator. I hope this shows up. Okay. Now we go to users, then source, lead1, pathos. Nice. Can do dr, I can do dir, and then I can do make link, package link dot swift, package dot swift. Okay, so now we have a link. The moment of truth is what happens if we run our metadata.exe here. Windows bin metadata.exe package link. Okay, we got our dump, and then the reserved value pause champ. Yeah, it's not 0. Cool. Woo! Okay, so for now, tentatively, I want to use this API then. Nice. Really good to know. Because this is, I don't know, like I just have, I learned about this API first, and then I got confused briefly in terms of how to implement, how to determine whether a file is a symlink. So, but I already have like a first impression of it. So I have an irrational reason to prefer it. But and as far as I know, like after some research, it's pretty good. It's just have an alternative of the other one. I don't know. Like maybe we'll use that later. But this is good enough. Good enough. Okay, and let's do some error handling, shall we? If this is an invalid value, we'll just throw our good old system error. And this is one of those things where I will, enhance it when I get to it. But for now, all system error just takes the code, and then we just throw out the code. Okay, so we get to play with this data structure. Yeah, so let's do it. I'm gonna open up the definition of metadata in our library, and you will see very soon the reason this structure looks like this is very much because of this Windows structure, availability of information of it. So first thing is we need to look into file time. So if you notice, one of the information here is, here we go. It's this file creation time, and it has a lower bit and higher bit. We want to convert it into our file time. So maybe, pretty sure I already have a file time plus POSIX. Okay, so that deals with a time spec struct from the glibc. So let's make a similar thing, and call it file time plus Windows, and then open that up. Condition it for our compiler. Okay, here we extension file time init, and we're gonna take a file time screaming case. I'm gonna import when SDK here. This will give us enough headers to work with this. And here's the interesting thing, right? A file time on Windows is two 32-bit integers, and it represents 100 nanosecond interval since 1961, January 1st in UTC. So we need to convert it into Unix epoch, and actually, I'm not sure, but also in our representation, we also have seconds and nanoseconds. Okay, let's do it one thing at a time. So let's get an int 64. Let hundreds equals. I'm gonna write some documentation here. Converts to Unix epoch and in library representation. So what is notable here is Windows file time is a 64-bit value representing the number of 100 nanosecond intervals since 1961, January 1st, UTC. Okay. So hundreds now makes more sense for the reader of the code. And what we want to do is take the time dot, what is it, DW high date time, I guess shifted by 32, and then or that, wait, shifted by 32, but also it has to be an int 64, right? Is this how you do it? You take an int 64, do that, and then you OR it with time.dw low date time. This can't be right. I think it has a little bit of a type incompatibility issue. Well, let the compiler tell us. Build. What is this? Did I delete the fatal error here? Like that fatal error is very important. Okay. Oh, so it builds. So this works. Nice. So now we have a 64-bit number that represents 100 nanosecond intervals, right? 100 nanosecond intervals. And then so how many seconds is between 1601 and 1970? Googling. Okay, here we go. So this is the number of seconds. I guess we'll make a constant here. Okay, seconds from Windows epoch. This number is 116. And then we'll have 3 4s. And then we'll have a 7, we'll have a 3, we'll have a 6, we'll have a 0 0. Okay. Just to be sure, how many seconds between 1961 and 1601 and 1970? 116,444 73600. Okay, and there you have it. That's an integer of 64-bit. Okay, so if we take the hundreds, I guess it's more clear if we say something like 100 nanos. Okay. We take that number, 100 nanos, divided by the seconds from epoch. Now is seconds from Unix epoch. Except it's not seconds, is hundreds of nanoseconds. Okay. So a nanosecond is, okay, a second has 1 to the 9th nanoseconds. So that means it's 1 to the 7th hundred of nanoseconds. Okay, so 1 to the 7th. Okay, since Unix epoch, 100 nanos since Unix epoch. Okay, so we need to create two values from this. So we're dealing with nanos in, wait, 100 nanos in 1 second. And that is 1 and the 7 zeros. 1, 2, 3, 1, 2, 3, 4, right? Six, seven zeros. Okay, and the number of seconds is 100 nano since in example divided by k100 blah blah blah, and then the other one is nanoseconds, right? That would be this value times 100. This should be correct. And this, I better write a test for this, right? I had better write a test for this. Okay, let's write a test for this. First of all, let's build. Okay, things built apparently, yeah. Okay, and then let's write a test for this. A Windows file time tests. Okay, and then import, well, let's condition this. Windows, is this our first? This might be our first Windows only test. So it's an important moment. For pathos, Windows file time tests, func test converting file time. Okay, so I need to construct this file time correctly, right? Let's just do epoch. Okay. Apparently, this is how my brain, my finger, like to spell epoch, E-P-C-H-O. Okay, epcho. And we take that epoch number, which is in meta Windows. No, file time Windows. Okay. We take this number, and this is the number of seconds from Windows to epoch. Okay. In 100 nanos. So this is number of seconds. Let's time it by, wait, we need to time it by this number. Oh, this is really big number. I mean, it's gonna fit in 64-bit, right? Yeah, it should fit in 64-bit. Let me try it real quick. I'll show you what I'm doing here. So let's just go to a random terminal. Not here though. Oh, probably here is fine. Okay. What is this number? 11644473600. That's, these should be 4s. 746000. Oh, times 10000000. Okay, so this number in int 64 should be a-okay, right? It is a big number. Is it smaller than int 64.max? I bet it is, because there were a lot of zeros at the end. Okay, so that's good enough for me. So there's our number, and we're going to take it apart. Oh wait, I should use unsigned integer, shouldn't I? This is a big trap here. Okay, unsigned integers is better. And then at the end, I'll convert it into our signed integers. This should be okay. And just to make sure, file time.swift are signed integers. Okay. Okay, so this is unsigned integer. And then we'll just do the reverse of this line, make it into two things. Import when SDK, and then okay. So we have our integer. We need to take the upper 64-bit and lower 64-bit, right? What's the best way? I feel like integer has its own like bit truncating behavior. No? Like unsigned integer 32 has a truncate. I hope. Let's play it on the Mac again. The thing about Windows is like it's not as easy to play with things. Okay, so we have this n, and then we'll print it out. Okay, and then let's try to convert it. So there's n, well, let's make it unsigned. Unsigned 32-bit integer truncating if needed, and let's print this. This should be our lower bits, right? It is 6927411120. There's no way this is correct. Okay. I guess we can just use a mask. Is that the best way to do it? Or we can use shifting, right? We take the integer. We definitely shift right to get the higher bits. But shifting... Oh, we can shifting twice. Shift it twice to get the lower bits. Huh. Okay, so let's try it. Let's try it. This is pretty interesting. Okay, so we take n, and then we say we shift it by 32-bit, and then shift it back by 32-bit. How about that? And then I need to use the right initializer. Init bit pattern. Clamping. Where did we get clamping? Okay. Maybe this will help. Cannot convert to the expected type in 32. Okay. How about now? What if I just print this? Wait, I'm confused. Oh, let's print it in binary. I'm dumb. Okay. So I'm confusing myself. Okay. So what is this? Like a string, and then what is radix? Yeah, radix. 2. Right. This is better. I was expecting to see the numbers to line up by their positions after shifting, which obviously won't work if you're not looking at binary form, right? Okay, this should work. Hard to say, but if you look backwards, there's a bunch of and then you 10011 10011. If the lower bits is right, the higher bits should be correct as well. Okay, so and obviously we'll have the higher bits. Higher bits would just be this shifted back. Yeah, so this lines up with this. Except the number of digits doesn't seem correct. $25. Wouldn't it be 32? Unless there's some leading zeros. What is the other one? Yeah. Okay. So there were some leading zeros, I bet. Okay, so this should be right. I mean, I have no reason to not believe this will be right. I guess the only thing left to do is let's convert them into int32 with bit pattern. Okay, and then this should look the same. I mean, really should be the same. So now we convert this integer into this, and then we'll stop there. No, I can't do this. How about this? Okay. Uh-oh. Not enough bits. Wait, what? Oh, ha ha ha. I see. Okay. So here's this, and this is the integer. So I need to take this out and put it here. All right. Lower bits 100, 1100, 100, 1100. Higher bits looks the same. Okay, good. So that's what we need to do here. Switch, bloop. Okay. So file time. I assume I can make this. And then file time dot dw high date time are the higher bits. So we take the epoch in hundreds, and then we shift it by 32-bit to the left, and then shift it back by 32-bit. So we erase the higher bit, and then we shift it back, and then we use a, I think the type is D word. D word, okay. D word. And then the low date time is simply this value. Oh, did I mess this up? Yeah, I messed it up. This should be just shifting the higher bit to the right by 32-bit. Okay. This one is the complex one, where we have to shift left and then right. It's like a juke. Let's juke it. Yeah, we shift away the higher bit, and then we restore the position of the lower bit. Okay. And then assuming that's correct, now we construct a file time, our file time. So file time of file time is that, and then we're gonna just dump it as well. Dump file time, and since this is the Unix epoch, we can assert that result.seconds is 0 and results.nanoseconds is 0. So now what do? Now we run the test, right? Test. Oh, got some stuff. Retrieving metadata crashed. That's fine. Metadata tests. Let's disable this test for now. Oh, yeah, then there's that whole shebang. Okay, I'm just gonna make this test harmless. And then we'll have to update our CMake list so that our new test file exists. Oops. So there's the CMake list. We'll put it at the end because like this file is generated anyways. What did I call it though? File time Windows file time tests. Okay, so now I'm thinking maybe the source file CMake list needs to be updated as well with Windows with a whole bunch of stuff. But mainly I'm interested in file time plus Windows. Okay. So having this, let's give it a little build, or actually remake. Build. Got our some cannot be applied operands of int64, uint64, and dword. Aha, so it never worked. It's just we didn't update this manifest, so I thought it compiled correctly. Okay, no fear. No fear. 64. File time initializer is inaccessible. That's awkward. Should it be public? Okay, so we're building and let's run the tests. We passed all the tests. And there's no way to know whether the test we wanted passed. Does this work? I wonder. What is the XA test? GitHub. What is this? I feel like the standalone executable has syntax to let you filter out the tests you want, right? For example, can I run build Windows bin Windows main list tests? Oh yeah, there we go. So we can totally filter them, right? For example, Windows file time tests, 0 tests. How does this work? Windows. What if it's fully qualified? Pathos test dot. So you can type random words in here. So there's a possibility that it doesn't match. Okay, so let's just find it. Windows path joining working directory Windows file time. Is this in alphabetical? Wait, it's not in here. Oh, it's not. I didn't update the manifest yet. That makes sense. Okay, so I'm a little concerned about this. Oh, this is a problem because this manifest won't get updated with my script on POSIX. That's a big problem. Windows file time tests. And what is our test name? This is our test name. Oops. Okay. Now if I go build and test again, still 76 tests. That's not a good sign. It's not in here, is it? Windows file time. No, it's not. Okay. Okay. What if I remake it? Still 76. Also, it didn't try to build anything. That's interesting. And we'll do make again. Test. I think 77 would be the right number of tests to expect here. Yeah, this is such a basic thing on non-Windows, anywhere but Windows. Okay. Okay. Just to make sure. Oh, can't double click here. Windows file time test is in here. Linux main doesn't care. Windows file time tests. It's an execute test case starting with test, blah, 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 and it works on Windows. Why isn't this listed? Windows binary test. Windows. It's not in here. Did I mess up the test format, manifests? Oh, I see. I think I know. At some point you need to add it into a big array, right? Yeah. Aha. So that's Windows file time tests. Windows file time tests. That's unfortunate because this for sure won't work once I generate this manifest again. Okay, let's just build list tests. Windows. It's not in here, right? Oh, Windows file time test. Okay. I, for some reason, expected this to be in alphabetical order, but obviously it's just whatever this order is. It's a list. Okay. So we can just run these tests now. And we have 2 failures. 2 failures. Can I run that test specifically? Windows file time tests. Pass those tests dot. Okay, here we go. This number is not 0 and that number is not 0. Okay. And here are the numbers we got from our dumps. Okay. So why wouldn't the seconds be 0 here? Oh, that's why. So that's the number of seconds, but obviously that's not big enough, right? I need to time this by the 100 stuff. Yeah, because that's the unit. Never do time math manually. Never. Unless you have to. Zero failures. 0 failures. We passed. Okay, nice. Now the real question here, well, is what do I do with this set of changes? And some files, okay. Some implementations, great. This I won't checking. This I will put in there, but it will be overwritten elsewhere. And then I guess I'll just add everything in sources and tests. Status. Wait, I thought I added everything in sources and tests. Okay. I can delete package link if I have the privilege. Oh, no, that's not what I meant. Package.swift. Okay. Delete package link.swift. Oh, I can. Even though I can't make the link, I can delete it. Interesting. Metadata windows, great. So I'm interested in seeing what the test generation behavior is. Origin head. So the branch name is Windows Metadata, I believe. Metadata Windows, okay. Fetch. Check out metadata. Oh, show you guys this as well. Okay. Metadata Windows. Okay, so that's our changes. I assume things are passes here. And then the real question is make code gen. This will generate some changes. Some files got formatted, that's fine. What I'm really interested in is the manifests. Yeah, I want to see what happened here. Yeah, our code got deleted. And it's never getting generated back. That's really bad. Okay, so I think, there's an easy answer here, right? We just have to make the signatures exist and the body empty for these tests. Windows, what's it called? Windows file time? Okay. So instead of condition here, we can condition here. Yeah. So this way this test exists and get added into the manifest. But it behaves correctly according to platforms. So on Windows, it actually does something, and on non-Windows, it does nothing. Make test, make code gen, diff. Okay, so it got added there and there. Okay. Let's see what changes the code gen did for us. So more files got added, numbers got formatted, and extra empty lines. Unused params, that'll be fixed very soon. What is this? Oh, I checked this in. That's unfortunate. Metadata tests. So this will be run as soon as we're done today. So keep that. What's this? If Windows SDK. So some sorting happened. More number formatting. and if. Oh, this is my manual changes. Okay, these are the generated files. Okay, nice. Man, I really miss working in this environment. Maybe I can stay here for a while instead of working on the Windows thingy. What was I looking at? Not this. This is you guys. Where's my research? I mean, this is all research I've done offline. Okay. All right, no problem. I'll just look it up here. It's find file data W. Find file data W. This is where our task is to convert this into our metadata object, and we've just did this 3 fields essentially because we converted the file time struct into our into our local file time struct. So let's do that in the actual initializer here, which is what? Metadata plus Windows, right? Okay, so here, take our info, or our data rather, or we'll keep the theta error at the end because I'm not going to do everything, but we have accessed, we have modified, we have created. So these 3 fields should be able to be converted directly. File time of data dot ft last access time. File time data dot ft last modify time, last write time. And file time data ft creation time, create time, creation time. Okay, sometimes Windows APIs reads okay. All right. The awkward part is like I have no way to know if this builds because this is conditioned on Windows. I'm running on Mac, so I'll switch it back as soon as I need to. Yeah, so this is just the beginning. We can, while we're here, do the file size one. So we have a size property. It's 64-bit. Yeah, the file size on Windows is, again, higher and lower bit with D words. So we can do int 64. Data and file size high, shift by 32, or that with, I don't know, maybe does this matter? I use unsigned integer to do bit manipulation and convert it back to the int at the end. So that it feels better, so I'm gonna do it. If it's not necessary, so be it. Int, then that's optimization for us later, right? Data and file size low. Okay. High, shifted by 30-bit. Low, stay in place. All the bits together. Now we got our 612-bit integer. And then we assign it to our property. That is just beautiful. Okay. We got a file name, but of course we don't need that. We need this thingy, which is gonna be very interesting very soon. File type is a JBait, I feel like. What is file type? File type, I mean. File type. Yeah, they don't even like mention file type. I think the meat of it is in the file attributes. So do I have a Windows permission? I have a file, but it's empty. Okay, so Windows permission. In here, I'm interested in this bit. Okay, so that would be I guess it's struct Windows permissions. I may have to make a attribute property. Windows file attribute, Windows attributes. This could work. Okay, let's condition this on Windows. So if OS is Windows, and then here, for now I'm just gonna put in the one bit is read only. Bool. And I think from this bit field, we also get whether this thing is a directory. So there's going to be a Windows file type, right? Windows file type, file, directory, symlink. Okay, this is okay, but this is the most complex implementation. Luckily, I did enough research offline, so it wouldn't take too much time online, I think, on stream. Okay, so what is... All right. So let's just take a look at POSIX permissions. It needs to conform to a thing. POSIX permissions conforms to permissions. Okay, I need to do the same for Windows. Windows permissions. We call it Windows attributes. Yeah, let's call it Windows attributes. Yeah, but I need to rename that again. Delete that extra S. Okay. So Windows attributes conform to this. Windows attributes. Okay. And it naturally conforms to it. It's as if this protocol is, built with the Windows API in mind. Okay, so let's make one of those for our permissions. So this permissions object is a existential, and as you guessed, yes, the type of the existential is permissions. We just made Windows attribute conform to permissions. So now if we make a Windows attributes here, it'll just work. Is read only. That information is from data.dw file attributes. And we want this value to be masked against read only. Okay, so hopefully that works. What else do we have left that's not the file type? We got file type is the beginning, and then we got the 3 times, we got size and permissions. Okay, file type is all that's left. Okay, at this point, I'd rather switch to Windows and make sure these existing things work. Okay, so code gen. Okay, I write flawless Swift, like formatter can't even do anything, won't even do anything against my code. Okay. Work in progress. Wait P. Okay, let's go back to Windows. Windows. Fetch origin. And then reset. Wait, should I do this? I feel like... I hope I didn't lose my shell scripts. Okay. Nice. Let's just build everything, right? Script make, script build. I just claimed that right. Flawless Swift. So naturally, now it's time to reckon with that. Yeah. Oh, yeah. Okay. 100 nanoseconds since epoch time. It's unresolved. What? File time. Plus Windows. It's unresolved. Oh. Where did it go? Did I accidentally delete it? Let's hope I can still... I mean, this number is what? Is the seconds from Windows epoch. Is our 100 nanos. 100 nanos. Subtract. Well, this is going to be a multiplication, isn't it? K100, blah, blah, blah. Right? We take the number of seconds from Windows epoch to Unix epoch, convert it into 100 nanos in, 100 nanos in unit. We divide that, and then that's the 100 nanos since Unix epoch. And then we do the conversion, blah, blah, blah. Okay. Well, we have a test for that. So, all right, now let's figure out the other one, which is the code we just wrote in, which file was it? Metadata plus Windows. Okay, so it's not happy about this operation because what? Oh, this operation. Because this is an unsigned integer and that's a signed integer. Something like that. D word unsigned and word signed. Why you do this? Okay. Uint 32-bit pattern. Hopefully this works. Right? You convert between signed and unsigned integers. That's when you use bit patterns, right? Oh, right. This is not C, so we have to write the correct thing and say this result of this is not 0. Nice. Okay. Let's add more working progress commits, because eventually they all get squashed and become a nice commit. All right, so let's do the last one, the file type. Okay, how should I do this? So there will be a few of these, right? So if this format with different attributes though, file attribute constants, there is a file attribute directory, I believe. Directory. Yeah. The handle identifies a directory. This is true, then file type is Windows file type dot directory. And then there are two other branches at least, but like yesterday I was reading the Python source code. They managed to translate the entire Unix file type map from Windows to Unix file type. So it's possible there's more than these types, but I'm willing to simplify this for now and say this is dot file. I'm gonna do symlink for sure, but the rest of the file types though is up for consideration. Windows file type is not, it's unused. What does that mean? Windows file type. Windows file type. Okay. Spelling errors. Oh, it doesn't conform to file type. Okay. Extension Windows file type, and we have a few tests. Is file Boolean? This is gonna be equatable. Then you guys can see this, right? Okay. So self is file is directory is symlink is sim. Okay, so that should make it conform to that. File time. Why did I say file time? Must be autocomplete. Make them public. No biggie. Okay. Wait, cannot save or something? Okay. So we've built, I think the best way to test this is use our sample app. So build Windows bin metadata package.swift. Oh, we've got stuff. Is it a file? Is it a directory? Okay. This is wrong, right? File size 713. Is there a way to package 713? Okay, at least file type is right. And then this time, let's convert it, right? Let's convert it. I want to show you guys the browser, but Unix epoch That time is 3 months ago on May 22nd, 2020. Looks right. That looks right. Okay, so I think the time I have a pretty good confidence about. Size I have a pretty good confidence about. Is the file type problem. File type is a problem. Oh, no. This should be file, right? That's a easy fix. Okay. Build test is a file. Now let's do the directory itself. Is a directory. Nice. The only thing left is a symlink. Okay. Now the most exciting event. How do we implement symlink? To answer that question, we're going to read some code, okay? I think the code we're going to need to read is Rust. So let's read some Rust code if I can find, if I haven't lost it yet. Rust metadata, blah, blah, blah. Okay, probably lost it, but that's fine. Reparse. Okay, so this is Python where we take the reparse tag, reparse point, IO reparse tag. Where's reparse tag? Reparse tag. Reparse tag is the reserved bit, I believe. Status. Yeah, it's interesting because Python uses behind file information, where I use is the find file. As I discussed at the beginning, like I had to choose between these two. Do I have the appropriate follow link implementation? Oh, I didn't think about that at all. Nah, it's fine. I'll do it later. So that's yet another thing to consider. So essentially, there's this attribute. You guys can see this, right? Okay, there's this attribute called reparse point or something. Reparse point, yeah. So a directory file that has an associated reparse point, or a file that is a symbolic link. So this is the first thing you need to check. But this is not the only thing. Okay, let me push the changes we made on the Windows machine down here. Okay, also work in progress commits. So the first thing I need to check was it's metadata plus Windows is else if data.dw file attributes and uint32 with bit pattern, this guy. So that's the first half of the condition. This is where we put symlink. Oh, I shouldn't have deleted the symlink file from my Windows machine, shouldn't I? Yeah, I need to keep it. Okay, but there's another condition, which is the tag thingy. this reparse tag. And reparse tag is passed in. Okay, so who calls this guy? This second one. This just says 0. That's not very helpful. So this is the declaration. This is 0. Let's look at this one. This is another declaration. Tag info reparse tag. Where's tag info from? Tag info starts from 0. Oh. Attributes from dir. Attributes from dir. They use find first file. Ha ha ha. They end up using the thing I used in the first place. You silly silly Python implementers. You are no match to me. Okay, this is the research, I think. No. This is for yesterday. We can close that. Close this. I know at some point I started reading Rust code. Rust, okay. So they have metadata or file. Yeah, it's not very helpful. Metadata. Lowercase. No. So I remember some. It's like in library. std. Right? Source. Then there's gonna be a file. No file? Oh, FS? Okay. No, that's tests. File.rs. Maybe metadata.rs. I feel like stat.rs. Nope. So FD, let's go back in history. Stat NT OS Linux. That's something. Source OS Linux. Oh, FS. Maybe it's here. Oh yeah, of course. There's gonna be a Windows equivalent of this. No? NT. Wait, am I blind? There's no Windows in here? All right. How about it's in here. Okay, hopefully this is it. Is symlink. There we go. Okay, so asymlink is conditioned on two conditions for Rust. First one is reparse point. Reparse point is the thing we just checked. Okay. And then is parse tag name surrogate. That's this thing. And it dealt with self self reparse tag. And reparse tag is the DW reserved 0. Only if it's a reparse point. Ah, okay. That makes that's actually easier than I remembered. Simpler than I remembered. Okay, so let's go to our library. Code pathos. Not this one. Metadata. Windows. Oh, it's open somewhere. It's open here. Okay. So they did something with the release tag, reparse tag. That's kind of weird. It was like they're adding it with this value. Reparse tag name surrogate. Is there a built-in value for this? Reparse tag. Name surrogate bit. Oh, is reparse tag name surrogate. It's a macro. Uh-oh. Why would you make it a macro? Microsoft bit. Reserved. Name surrogate bit. This bit. Okay, I'm just gonna do exactly what Rust does. Okay, so we at least really have all the value here, right? So this value needs to be not 0 and data dot DW reserved something 0. Reserved 0. Okay. This guy and masking with this value is not 0. Thanks, Rust. That means it's a symlink. Okay, let's try it out. Push it up, switch computer. Okay, and let's hold it down here. I'm just gonna build everything, right? Didn't add a new field, so new file. Okay, so build Windows binary metadata. This still works. Okay, now I need to make a honest symlink. So I need to do that thing again where I go to prompt, run as administrator. Make sure you guys can see this. Yes, you do. Then go to user stand source pathos. Okay. Let's make a link here. Make link target a dot swift. Okay, so now we have an a dot swift. A dot swift is here. It says symlink. Okay, good. Now we need to test here. A dot swift. Please be a symlink. Yes, it is. Nice. So it works. Oh, sorry. Can you guys see that? You probably saw it, right? It's on the bottom. Okay. Nice. So I know it works. There's no proof other than this video. We will come up with tests in the future because there's some complication when it comes to running tests with with assets on Windows that I need to figure out first. Okay, the last thing for metadata, at least for retrieving metadata. We're almost at 2-hour mark. Okay, the last thing for metadata is the follow symlink thingy. Follow symlink. I don't know why this wasn't causing a compile error. Let's see. Paths plus POSIX or metadata. Yeah, there's a follow symlink here. And then here there's another follow symlink. Okay. Yeah. Default that to false. Okay. Okay, so here's the interesting thing, right? We got the result here. But we can't return it yet. If we're following symlink and the result dot file type is symlink, then we have to follow that link. So really, we need to do like something like this. While follow symlink, the result is symlink. We need to keep going. So we need to basically read, resolve the name to follow the link. Yeah. Let me switch back to the Mac. Okay, so let's look at how do we follow a symlink. Create symlinks. Symbolic links. So there's a function that gets you the actual path, right? File flat create. If this there's no change in behavior. Okay, this is something to think about. If the call to this function creates a new file, there's no change, okay? If this flag is specified and the existing file is opened and it is a symlink, then a handle returned is a handle to the symbolic link. Open reparse point. So I actually want this. If it's not specified and it's open and it's symlink, the handle returned is a handle to the target. Interesting. But we just saw I'm not specifying this flag, am I? Let me see. Find first file. Oh, I'm not using create file. Find first file. Contains the information but the symbolic link and not the. Okay. Okay. So we need to resolve the same link. Get file attributes. Get file security. File management, obtaining and setting file information, timestamp, current character set code page, determining size of file, searching, setting timestamp, determining the current character set code page, reading and writing, following directory linking. Hard link conjunctions. Sparse files, symbolic links, sparse files, operations. When creating a symlink, operating does not check if this target exists. No. That's just basic information about symlinks. Okay. Real path windows. Full path. File handling. I mean, this is the C library functions, but I want to use the Windows functions. Real path windows. PHP, okay. GNU toolchain. No. Real path symlink Windows. Of course, Python result takes precedence. I mean, I can just read Python's code. But I remember seeing it. That's Python Symlink Windows. Relevance, Python Symlink, remove git Symlink, create directory Symlink. Detect Symlink. Oh, I should say follow Symlink. This is the right question. I just need an example. The example, I've seen an example somewhere before. It's a particular function that you call to get the thing. Maybe Symlink Windows. API. Create Symlink. Is this the answer? No, this is user's perspective. Oh yes, get final path name by handle. Finally. This is the function. So we get a file handle, which is kind of awkward because we never made a file handle in this case. Luckily, we do have the file name. So we can create a file handle. Retrieve the final path for the specified file. Let's just read the example in the Stack Overflow answer. So they use open file, of read, file name of read. What is of abstract? Okay. Interesting. This would also be an implementation for real path. Normalized. Okay. If this succeeds, the return value is the length of the string received by the path thingy. Path not found. Not enough memory. Remarks. Blah 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 blah. Okay, let's give it a try. So we need to first open the file. So let's go open file. W. No, open file. What is this? Create file. Okay, let's use create file. Wait. Before I go too far, I feel like didn't I have that at some point? Yeah, I have this. Create file, normal, overlapped, open existing. I don't know what this, the correct flag of this should be. There's a specific flag that lets you open the directory. And that's gone. Okay, no fear. We have that Python code somewhere that we can read, right? Okay. Create file. Code C Python create file W. Open existing flags. Open reparse point. Yeah, so I guess this is the interesting. This is the advantage of using the other API, which is you can directly specify that you want to deal. You want to follow the link. Okay, so let's do the create file thingy. Okay. Create file. And then we have our binary C string. We have a generic read. We have a D word file share read. File share read? Is that the right flag? File read attributes. Oh, I just realized you guys are not seeing what I'm typing. File read attributes. Is that enough? feel like I need to read the content though. Okay. Then we have a nil coming up. Then we have a D word open existing. Then we have a D word. This is where the reparse point comes up. File flag open reparse point. Because we're trying to resolve the symlink. So that's actually the key thing. The key parameter. For the nil here. Okay, so now we should have a handle. If the handle is like invalid handle value, we throw the error. Okay. Now we call that other thing we found. Okay, we need a buffer. How do I do this? Yeah, it's something like this. Okay. So this is how we do it. We use this thingy, which gave us a uninitialized access to the memory. Then we get two variables to play with. And the thing we want to do is get final path name by handle. We have our handle from above. And then get final path name by handle. Okay. This probably needs to be like that, but who cares? This is our buffer.base address, and then this is max path, and then we have the flags. So in the opened. Let's just use 0 here. Okay, so this value, this function, if it succeeds, return value is the length of the. If it's 0, then we have a problem, right? If this is 0, we throw this guy again. If this is not 0, Let's find out. Can you use Sterling in here? Probably not, but maybe. So we create a new path from the contiguous array we got, and then we just return its metadata. There's no way this works, but we'll see what goes wrong. Scripts build. Lay it on me. Result. Result. Aha. The word. Yeah, that's not the thing. The word. Okay. Get final path name by handle. Get final path name by handle W? Okay. So this needs to be a D word. And so is there like a W char Sterling? WCS Lin? Cannot convert value of type unsafe mutable buffer pointer of this. Yeah. Base address. Oh, this is in a while loop. Result equals this. Eventually we'll return result. And that should make our function compile. Okay. Wait, did I delete the symlink? That symlink has proven itself useful, so I need to keep it around. So let's open the command prompt, do the whole thing again. Users, thing, source. Okay, this thing doesn't remember anything. Make link. Okay, this thing is a symlink. Now what? I guess now we have to modify our sample app. Examples. So how do I do this? Follow symlink equals command line arguments to dash s dash f. Okay, and then follow symlink. Okay, let's give it a build. And let's run this again. Uh-oh. Oh, yeah, of course. Need to guard this. Count is greater than 2. Oh, and okay, so this still works. Now let's add dash f. Uh-oh. It's hanging. That means it's stuck in a loop, right? Description. Okay. Build. Test. So it's stuck on here. Which means our get final path by handle didn't work. Wait, also this path looks weird. Maybe let me try this. File name opened. D word. Nope, same thing. Stuck in a loop. Okay, let me show you what I'm doing right now. Okay, so I'm in the C Python implementation again. So I'm looking at definition for read link. Read link is os.readLink. Okay. So we're looking at something like this. Read link implementation. Okay, here we go. Bytes returned, reparse point handle, buffer, okay. Create file, open existing. Let's follow this. So they used 0 here, right? And then they used the 0 here, I believe. I mean 0 literally. 0, 0, nil. Open existing, and then they have file flag open reparse point and backup semantics. Oh yes. File flag backup semantics. So this flag makes it so that you can open symlink to directories or something like that. Okay, I don't expect this to change anything, but we can give it a go. Yeah. So if we got the handle, what is this? Device I/O control. Device I/O control. What? Is this a real thing? Come on. Device IO control.self. Is this available to me? It is. We get this, we get this. target buffer, size of target buffer, and bytes returned and 0. Oh, that's it? Thank you, Python. That's really nice. Size of target buffer. Okay. So instead of this business, we will do, well, that's ugly. Let's do this. Okay. We will do, what are they doing with the result? If this is complete, this is non-zero. Okay, if it's 0, then okay. So if device IO control, we have our handle, we have FSCTL, file system control, get reparse point, and then we have a couple of zeros. Then we got a buffer, we got our max path. What are they using for path? Pi maximum reparse data buffer path. What is this? 16 times 1024. Huh. Should I be using that instead? Okay, sure. And then we have a nice value that tells us the returned number of bytes, right? And it's a D word, so let's get one of those out here. Length. And then we have a nil. If this thing is 0, we throw system error code get last error. Otherwise, we've got a buffer. And our count would be length. This is beautiful. And also this is obviously wrong. So max path for now. Pi maximum reparse data buffer size. Okay. Remember to research that into. Okay. To do. Okay. Build. Okay. Convert the word into int. And then looks like one of these voids should be nil. on line 48. Zero cannot be applied to int and bool. Oh, this is a bool? Okay. And I think this needs to be converted to a D word. What else? Buffer base address. Nice. Wait, what? Error code 0. Did I flip this condition? Error code 123. What is error code 123? Windows error codes. Windows 3, the following direction symbol syntax is incorrect. I bet it has something to do with handle. Is it thrown here? Some indentation is really messed up here. It was not thrown here. It must be here, right? I mean, it has to be there. I don't get it. Why does this answer not work? Get final path as the path returned when the path is fully resolved. For example, simply I mean, yeah, that's what I tried earlier. And it didn't work. Didn't freaking work. Okay, so at least this thing is not throwing errors. Let me try that one last time. Check the return value. If the return value succeeds, fails because the path is too small, or actually return value fails for any other reason, return value is 0. Oh, wait, what? So we got the lens for free here. That's better. But this just threw us in the loop. It doesn't actually resolve the see also. Oh, I see. I see. I think I got it. Let me try to show you the screen here. I think the problem is I was using this. So I kept opening up the reparse point when what I want is to not open reparse point, right? Yes. That's it. That's it. Yes. Okay. So if I don't use the follow link flag, we will get the metadata for the symlink. But if I do use the link flag, we'll get the metadata for non-symlink, which happens to be the file for package.swift. See, the length is matched here. Oh, I'm so glad I caught this. Okay. So where does this put us? I think I'm done for now implementing as far as implementing the metadata goes, we're done. So you know, this commit can be whatever. I'm gonna rebase against what is my metadata? Yeah, metadata. Okay, so all this little weird thingies. What? Just squash all of them. And why is this weird? This is the Vim, not this is Vim, not NeoVim. Okay. Implement fetching metadata for Windows. Okay. All right. Scripts test. We have 77 tests passing, and there should be a metadata test. Yeah, so this test is a very simple one that just checks the current working directory's metadata, make sure it doesn't throw, and make sure that the file type is directory. So I think we've just verified that it works on Windows now. Or has it always been? I feel like it's been passing for a while. Maybe not at the beginning of the stream. But yeah, there we go. Let's go to here, make a pull request against metadata. I also am curious about the whoa. Why is this so there are so many things here? No. Why were there so many commits? I thought I squashed everything. Okay, hopefully that fixes the commit problem. One commit. Yep. Okay. Thanks very much for watching. I'm gonna call it for now. Again, I stream on Twitch, so feel free to follow me there. If you're watching this on YouTube, give this a like and follow my channel there as well. Subscribe. Thank you very much. Oh, I just realized for a long time you guys are staring at the command prompt. I'm so sorry. I'm new to the Windows setup, so but hopefully you guys can see the right half and the bottom half a little bit. Whoops. Okay. Have a good one.